from many different points of view. Okay, so supercritique of Einstein. Thus Einstein took us beyond Kant, since now we can know the world, but he tragically reintroduced the antimonies of Kant's monumental critique of pure reason! And we went beyond Kant by using a priori method and uniting it with Einstein's a posteriori method. And Kant's antimonies are also useful in refuting the Aristotelian philosophy. This does not include the logic of Aristotle, which Kant accepted completely. And Einstein really restored the problems of Aristotle by criticizing Kant also. Let alone all the paradoxes that Einstein created and confused everyone. But enough, the theory is not understood even by most specialists in physics. Really, in a way, even SR is already a unified theory, since unlike Galileo, it uses light waves to observe the world, and also GR, which uses SR besides gravity and the EM energy tensor. And even QM, since Maxwell saw light as a wave, electromagnetic fields, and Einstein saw light as a group of particles, photon. One of the key principles of QM is wave-particle duality. So the question arises, which kind of entity is light? In a way, Einstein contributed to quantum mechanics because of wave-particle duality of light. He actually even influenced Max Born because he did a similar thing for electrons, to interpret electrons. Okay. Okay, and Niels Bohr suggested that objects can be both at different times depending on the circumstances. Which kind of entity should you thus use in deriving the theory of general relativity? But all that matters seems to be the speed of the wave, whether it is made up of particles or made up of EM fields propagated through space. And the speed seems to be the same in both cases, for otherwise you would get two theories of SR and two theories of GR! My theory, Joseph Beaton. Unlike Bohr, maybe what you have is a wave of particles that are charges so that they carry an electromagnetic field as well. The truth being that light is both a wave and also a particle in nature. Dirac argued that the matrix mechanics QM of Heisenberg and the wave QM of Schrödinger are identical. Here, the light is not passed through slits, and there is where it may seem to be a wave, nor does it have a particle nature as in the photoelectric effect. Maybe the latter proved that it's made up of particles, and the slit experiments were the results of misinterpreting the experimental data, since the particles going through the slit and the crystal itself and the wall where particles hit really charges with electric and magnetic fields, not neutral masses. So it was naive to expect that the electric and magnetic fields should have a wide spectrum of effects that should not have a wide spectrum of effects results on the wall. Okay, granulification theory. We really need to replace the approximate mass, quote-unquote, and gravity, quote-unquote, concepts of Newton, whose status is godlike, almost among people, even geniuses in physics like Einstein, or the quantum physicists like Max Born, with the exact concepts of charge and electricity of Coulomb and others in SR and GR. Critique of Max Born, etc. He got a Nobel Prize for his introducing the notion of probability into physics, but maybe Einstein is right, there is no chance out there. Really, it is simply that our knowledge of the world is limited, using the methods we use to investigate it. Supercritique of Einstein. It seems that Einstein theory is all wrong! Space and time and motion, other physical properties of objects in the world, are not modified by the motion or acceleration of the objects or of the objects observing them, the physicists. His theory only expresses mathematically what we already know about the world, namely that light waves have a limited way of revealing the world to us, and the equations are really only an estimate of the error of our knowledge of the world. Einstein criticized Kant for claiming that nothing can be known about the world, but he did not go into the opposite extreme. But did he go into the opposite extreme and claim that everything can be known about the world, or too much anyway. That is only limited by our abilities. Okay. Since these effects, this affects his theory. Since the effects his theory mentions, like time dilation or length contraction, or length curvature in the real world, are there such things? Exclamation mark. These are only the result of the distortion of perception due to motion and the fact that we use light to observe the world. Light is a great medium for this end, but it is limited because of several reasons, like its speed or the size of its element when it is used for observing very fast things, SR, or very small things, QM. We still need these values in absolute sense using Galilean transformation. We still know these values in absolute sense using Galilean transformations. Yeah, but how do you obtain these values? Oh God! Exclamation mark. The error is the difference between the Galilean transformations and the Einstein transformations for SR. But we need to create a pre-relativity Beton question mark transformations for acceleration, rotation, or revolution, since Galileo did it only for linear motion question mark, and calculate the difference. But how can you obtain the real Galilean values since you use light to observe the world question mark? So even SR and PR are incomplete and are part of psychology really, and we need to add a theory or step to infer the Galilean values in the world. The greater the relative speed, the greater the error. QM. Heisenberg and Schrödinger, Born, Dirac, Einstein, etc. just tells us the probability of finding an electron in certain orbit inside the atom. Usually only a very small atoms since it gets too complex, plus you ignore the effect of different electrons on each other and only consider the electron-nucleus interaction. This is similar to the fact that you only consider the planet-Earth interaction in the cosmos. The reason is that otherwise you have a many-body interaction instead of only two-body, and this problem Newton held to be beyond his abilities, like I said before. Though recently some physicists have made progress in this area, but what new techniques are applied to our world should also apply to the macroscopic SR and the microscopic QM as well, since they think that it is not possible to know the exact location of electrons in space as demonstrated by their so-called slit experiment or the duality of light experiment, and also the famous uncertainty relation of Heisenberg, his Nobel Prize, which states that you cannot know the position and momentum of a particle or wave completely at the same time. The more accurately that you are able to measure one, then the less accurately you are able to measure the other. It's from page 12. So we're about halfway there. Is the fallacy that you make, is that like that the case of relativity theory, that this is really psychology, not physics, question mark? A limitation of our perception and not a limitation of the world itself. And the reason of the fallacy is that light is limited in allowing us to observe very small objects like electrons, just like light is limited in allowing us to observe very fast moving objects or accelerating under a force objects in the theory of relativity. Really, Einstein is right. God does not play dice with the universe, or usually, contrary to QM. The world out there is not ruled by probability as physicists believe, but it is only that we lack full knowledge of the world and we rely on light, which is limited usefulness in revealing the world to us. Electrons can be known in orbit of nucleus just as much as planets can be known in orbit out of this orbit of the sun, except that we use light. But light is great when you observe macroscopic things moving slowly or objects that are big enough. For example, we don't see faraway stars, since the light from them takes millions of years to arrive at our eyes, let alone if it is annihilated on the way because it loses its energy or on such a long journey, or the gravity of some star does not deflect it on another direction away from us. I think physicists didn't consider this before Einstein. Even Hubert Reeves didn't mention this when he considered why our planet is not too hot or the sky is not full of white light. For microscopic objects, it may be necessary to use the wave of subatomic particles that has been discovered recently, like quarks or leptons, or maybe gluon wave instead of a wave of photons. Some of these may be smaller than even photons and are charged, so carry an EM wave as well. Maybe even there is another medium that can be used, and if we can't use it, then maybe machines can be built and can be used and then reveal the results to us by a suitable transformation. Supernova, oh God, exclamation mark. Einstein is tricky, exclamation mark. The general theory of relativity psychology, that is, its essence really, in essence really, the theory of relativity accepts the pre-relativity mechanics of Newton's mass and Maxwell charges and magnets views, but now takes into consideration the fact that light is used to observe the world, unlike Galileo. Really, it is divided into two major cases: linear motion, which is based on inertia, no force of any kind in SR, and nonlinear motion or force in GR, question mark. Einstein uses partial differential equations, which is part of advanced calculus or even tensor calculus, let alone that they are tensors. These are simply vectors in a coordinate system plus a transformation equation to another second coordinate system, and the mathematics is complex and methods exist only for some of these equations, especially nonlinear partial differential equations. These are solved by using numerical approximation methods on computers, but Einstein said that need an exact analytical solution to these field equations, so need an advance in mathematics. And also he said that need to define the energy tensor of matter, which appears in the field equations, and he could not do it. So he said, because of our ignorance of the laws of distribution of charges inside matter, so we need an advance in physics. Relativity considers perception, since both observers use light to observe the world, and is the same speed for both of them. But if light speed is affected by the relative speed, then it is negligible anyway, since objects move far slower than the speed of light. So it is a good approximation. They show that even the speed is not fast enough to affect the speed of light in the Michelson-Morley experiment. Though really, if the experiment is valid, if our eyes cannot detect such a minor fringe shift is needed, question mark, is it valid? The following is a summary of the general theory of relativity after studying it for about 35 years. Case 1, SR1. When the object is at rest, not moving relative to you, then your perception of it is like that of the perception rather than at rest relative to it, and the major result is equals mc squared. Use classical mechanics of Newton and classical electromagnetism of Maxwell to derive the laws of motion of SR, and then remove the parts in the equation due to motion. Really, time may be still distorted in that you don't know a planet or a star existence is far away, and light from it didn't get to you, or may have passed your point long ago. Case 2, SR2, just compares your perception of an observer of an object that is moving under no force in a linear fashion, inertia alone, a force applied before and removed, relative to you, to the perception of an observer of the same object by someone who is stationary relative to the object. Case 3, SR3, just compares your perception as an observer of an object that is moving under no force in a linear fashion, inertia alone, a force applied before and removed, relative to you, to the perception of an observer of that same object by someone who is also moving under no force in a linear fashion on the same path but with a different speed, inertia alone, relative to the same object. So SR applies to both of your perceptions of the same object, and you just relate your perception to his perception. Case 4, for the general theory of relativity, GR just compares your perception as an observer of an object that is moving under a force, have curvature of revolution or rotation, and possibly inertia, to the perception of an observer of the same object by someone who is stationary or moving but not accelerating, or no curvature relative to that object. That is, SR applies to the other observer, but is more complex in your case. Maybe it covers both cases of objects curving in orbit around you, and object curving away from you as well. Page 5. Did Einstein discuss the question mark? GR2 just compares your perception as an observer of an object is relatively accelerating to you, i.e. it is moving under a force, half curvature of revolution or rotation, or you are moving under a force, and possibly there is inertia to the perception of the same object by someone who is also relatively accelerating by a different degree of acceleration relative to the object. Is this a more complex theory than general relativity? Question mark. Indeed, long ago they gave a prize to someone for someone to describe the theory of relativity in a few sentences, and Einstein said that he could not do it! Exclamation mark. This is from page 14. All quantum mechanics does is give two major ways of describing objects, i.e. electrons in orbits in atoms, similarly to what Newton did 300 years ago for the orbits around the sun and the cosmos, or our solar system. They added the theory of probability since objects are very small in atoms and light is used to observe them. Also because of slit experiments, so it's difficult to observe small objects. The electron is 1,000 times lighter than the neutron or proton in the nucleus. Okay, postmodern psychology. Really, Immanuel Kant argued that we have limits in what we can know. We can only know psychology partially even. We limited our intellect and our sensory organs. David Hume really began the skeptical attitude in a major way. Or maybe Ghazali, or before that in Islam, or Kreskas in Judaism, or Galileo in Christianity. Albert Einstein really showed that we can know the world using our senses, but the sensory organs are limited as a source of knowledge since we can